Good morning, children. In the previous class, we have studied about what is the meaning of a capacitor. You studied with us, it is an arrangement to store large quantity of charge in a conductor by placing an uncharged earth conductor near to it. If both these conductors are parallel plates, we are calling it as parallel plate capacitor. Now, how to find the capacitance of a parallel plate capacitor? Previous class, we defined C as C is equal to Q by V. How to find the expression for Q by V of this parallel plate capacitor? That is a question. So, you consider the parallel plate capacitor. Already told you, if the charge on this plate is plus Q, the charge on this plate will be minus Q, as it is earth. So let the gap between the two plates, that is D. D is the separation between the two plates. Positive charge Q on this plate, minus Q on this plate, the potential difference between the plates, that is V. V is potential difference between the plates of the capacitor. D, distance between the plates of the capacitor. A stands for area of each plate of the capacitor. So Q by A, that is called surface charge density of this capacitor, that is plus sigma, and the surface charge density of this one is minus sigma, minus Q by A. In your Gauss theorem, we discussed the same idea in the second application of Gauss theorem, that is electric field due to a charged sheet. You know, electric field due to a charged sheet is sigma by 2 epsilon naught. But if you keep two parallel sheets of equal and opposite charge density, how much electric field is there in region 1? Region 1, your electric field is, how much electric field? It is 0. In region 2, how much electric field is there? That is sigma by epsilon naught. And in region 3, how much electric field is there?
0.
That is again 0. So, we studied like this. If two parallel plates with equal and opposite charge densities separated by a distance d, then in between the plates an electric field, what is the speciality of this electric field? It is uniform electric field. Uniform electric field, non-zero electric field, sigma by epsilon naught, that is existing only in between the plates of a capacitor. On the left side and right side space there is no electric field. That is what you studied. Now use the same concept, and you studied one more thing in your previous class. What is the relation between electric field and electric potential? Can you tell what is the relation between electric field and electric potential? It is E is equal to minus dV by dr. What is the meaning of this? Negative potential gradient is called electric field, or E is equal to dV by dr in magnitude. That is what we studied in the first year. You apply this concept to this parallel plate capacitor. So instead of electric field, you can write sigma by epsilon naught. Electric field between the plates of the capacitor, that is sigma by epsilon naught, is equal to. What is dV stands for? dV is called potential difference. Here the potential difference between the plates of the capacitor is V. And dr stands for distance between the plates, and the distance between the plates you can see it is d. So here V by d stands for potential gradient, and sigma by epsilon naught, that is the electric field. But you know sigma, lambda, sigma, rho. Sigma is charge upon area, Q by A. So instead of this sigma, you can write Q by A. So your expression becomes Q by A epsilon naught V upon D. What's our aim? You have to reach C is equal to Q by V. Now you see, Q by V, numerator by numerator is equal to denominator by denominator. Therefore, what is Q by V? Q by V is equal to A epsilon naught by D. This is the capacitance of your parallel plate capacitor. So, capacitance of the parallel plate capacitor is equal to A epsilon naught by D. What is A stands for? Area of each plate of the capacitor. And what is epsilon naught? Absolute permittivity, or permittivity for free space. and D, distance between the plates of the capacitor. Now there is a question. Here epsilon naught, what is this naught indicates? This is called absolute, or what is the medium in between the plates? Air or vacuum. If air is the medium in between the plates, then it is sigma by epsilon naught. If the medium is other than air, if the medium is a medium other than air, in that case, instead of epsilon naught, what will be coming? Epsilon is coming. And you know, epsilon is equal to k epsilon naught. This is capital K epsilon naught. What is this K stands for? K is called dielectric constant of the medium. If you use that concept here, what you are going to get? If air is the medium between the plates of the capacitor, then the expression for capacitance is A epsilon naught by D. This epsilon naught indicates that air is the medium between the plates of the capacitor. If the space of the capacitor is filled with a medium other than air, then the same capacitor, so there is no change in D, there is no change in area. Now instead of epsilon naught, what is coming? Epsilon is coming. And epsilon by epsilon naught is called dielectric constant of the medium. So instead of epsilon, you can write k epsilon naught. So this will become k, which k is not Coulomb constant, it is dielectric constant. K A epsilon naught by D. If you divide second equation by first equation, what you are getting? C medium, capacitance in the medium divided by capacitance in air. If you divide, you can see all these terms are cancelling and you are getting dielectric constant. In the first chapter, we studied dielectric constant is equal to epsilon by epsilon naught, and that is called relative permittivity epsilon naught, and that is equal to force in air divided by force in the medium. All these are different expressions for dielectric constant. Suppose in the question paper, if the question is asked, define dielectric constant in terms of capacitance. That's a previous body question paper question. So the answer is capacitance with the medium between the plates divided by capacitance with air as the medium between the plates. That ratio is called dielectric constant. Capacitance in air is A epsilon naught by D, and capacitance for any medium between the plates is equal to K A epsilon naught by D. Now the question is, in which medium, for which medium the capacitor is having least capacitance? It is very clear, it is for air. Why? Because you know K is always greater than 1. And K is equal to 1 for what? K is equal to 1 for air, and that is the least value. So K is least. So you can see that here 1 A epsilon naught by D is there. So if air is the medium, your capacitance is least. So if you introduce any medium in between the place of the capacitor other than air, the capacitance goes on increasing. That is the meaning of this equation. Now you tell, what are the factors deciding the capacitance of a parallel plate capacitor? It is very clear from the formula. The first factor is the nature of the medium between the plates. If you keep different medium, different K values are there, capacitance changes, area of the plate of the capacitor, and D, distance between the plates of the capacitor. So these three factors basically decides the capacitance of a parallel plate capacitor. Suppose one question is like this. The capacitance of a parallel plate capacitor in air is 10 microfarad. What is the SI unit of capacitance? C is equal to Q by V. Its SI unit is farad. And you can see microfarad, picofarad, etc. 1 microfarad is 10 power minus 6 farad, and 1 picofarad, that is 10 power minus 12 farad. We have to use these two conversions while doing the numericals. So there is a capacitance, parallel plate capacitor, capacitance is 10 microfarad. If area of each plate is doubled, and the distance between the plates is hard, and the material of dielectric constant 80 is introduced in between the plates of the capacitor, what will happen to its capacitance? That is the question. In air, the capacitance 10 microfarad, you are doing three changes. One is you are doubling the area of the plate of the capacitor, and you are reducing the distance between the plates to half, and you are introducing another material whose dielectric constant is 80 in between the plates of the capacitor. If you make these three changes, what will happen to the capacitance? That is a question. It is, you know that it is a very simple question. It is based on this area, C medium and C air. C air, the formula is A epsilon naught by D. In the question, that is given as 10 microfarad. Equation 1. Now you are making many changes. You are changing the area, you are changing the distance, you are introducing a material in between the plates. Now what is the new capacitance? K A epsilon naught by D. This is the basic formula. In the question it is given that area is doubled. So instead of A, you have to write 2 times A. And distance is half. Now you see, these two and these two together, it will make 4K. A epsilon naught by D. So your answer is 4 into 80 into A epsilon by D is 10 microfarad. From this, it is very clear that if you change area, if you change the distance between the plates, or if you change the medium in between the plates, the capacitance of the parallel placed capacitor changes. That is the meaning of this question. Now, one more question that is based on this. There is a charged conductor. Okay. If you are placing, question number 2, if an uncharged earth conductor is placed, uncharged earth conductor is placed near to a charged conductor, what will happen to the charge on the plate A and potential of plate A? What is happening to charge on plate A and what is happening to potential on plate A if an uncharged earth conductor is placed near to it? This one you can do as a homework question, because this is already discussed. Where we discussed this principle of capacitor. Just tell what is the answer. By placing this one, what is happening here? Minus. So what will happen to charge on plate A? There is no change. And what is happening to potential of A? Because of the presence of this minus charge, potential of A decreases. And one more question based on this. We have seen C is equal to Q by V. So the question number 3 is, this is a graph which has got more capacitors, A or B, which has more capacitors, A or B. It's a very simple question. You know C is equal to Q by V. For the same value of Q, see, the voltage for A, voltage for B, you check. This is V for A and this is V for B for same Q. The Q is same. If you divide voltage of A, you will get capacitance of A. If you divide with the voltage of B, you will get capacitance of B. Now you just compare. Charge is same, but V of A is smaller. V of A is smaller means C of A is smaller. Which has more? So what is your answer? C of A is Q by VA and C of B is Q by VB. That means same charge, the potentials are different. Now see, for A, the potential is less. Potential is less means denominator is less. Then CA is more. Therefore, capacitance of A is more. So C of A greater than C of B. This one you can think it in another form. C is equal to Q by V or delta Q by delta V. That is called C, and that is called tan theta, and that is also called slope. So the graph that is having more slope means more capacitance. More slope, more capacitance if the graph is Q by V graph. So definitely it is very clear. A is having more slope and hence more capacitance for A. Now I am going to change the question. This is VQ graph. Which has more capacitance, A or B? Now here you see. This is just opposite to the previous. Here, what I will do is for same Q, what is the variation of the voltage you check? See, same Q. V for B is this one, and V for A is this one. See, same Q, same numerator, V of A, V of B. Same way of thinking. Q is same, numerator is same, and very clear from the diagram, VB is less. If VB is less, CB is more. VB is less, therefore capacitance of B is more. See, so based on the graph, you have to tell the answer. If it is QV graph, Q potential difference graph, charge potential difference graph, more slope means more capacitance. If it is VQ graph, less slope, meaning more capacitance. That is the meaning of this graph. So the graph between V and Q, potential difference and charge for a parallel plate capacitor is a straight line passing through origin. And one more question you can see, that is question number 5. What is the ratio of electric field intensity of electric field between any 2 points A and B, between the plates of at any 2 points A and B, between the plates of a capacitor. So there is a capacitor, there is a point A and there is a point B. You have to find what is the ratio of intensity of electric field between A and B. So electric field at A, you know, that is sigma by epsilon naught. And electric field at B, how much? That is also sigma by epsilon naught, because electric field between the plates of a capacitor is uniform, same. So what is the ratio between the electric field? That is 1:1. Thank you.